So the third method of solving systems of equations is through elimination. So it's important to note that any two quantities that are equal can always be added or subtracted from both sides of an equation. And that's going back to the basic rule of math, which says if you can do something to one side of the equation, you must do it to the other. So the elimination method is useful when you can eliminate one of the variable terms from an equation by adding or subtracting another equation. For example, if you wanted to look at this equation, 15x plus 7y equals 4, and 5x plus 7y equals 2, well, if you wanted to eliminate the y variable, all you would have to do is to make the second one negative. So make the second 7y negative. And if you did that, then the y's would combine those equations together, then the y's would completely disappear. So the key to using the elimination method is to find variable terms in the two equations that have equal or opposite coefficients. So the key to using the elimination method is to find variable terms in the two equations that have equal or opposite coefficients. So in this particular problem that they gave us, they had equal coefficients. An example of something with opposite coefficients would be 3x plus 2y. You don't have to write this down. Equals 12. And 4x minus 2y equals 8. So these would have opposite coefficients because one is positive and one is negative. So the next portion asks us to write the 4 steps of the elimination method. So our first step in the elimination method is to find the variable with equal or opposite coefficients. So find the variable with equal or opposite coefficients. Our second step is that if they're equal, subtract the equations. And if they're opposite, add. And we'll go through some examples that talk about what all this means. Step number 3 is to solve the now one variable equation. And the fourth step is to substitute the known value into the other equation and solve for the remaining variable. Again, we're going to do some problems and talk about what each of these means because it's just a lot of words that I know seems very overwhelming. So, we have a problem. Solve the system of equations to the right and enter your answer as an ordered pair. So, what we're looking for when we're solving systems is we're looking for variables. Step 1 says to find variables with equal or opposite coefficients. So, if you'll notice, we have a negative 8y and a positive 8y. So if I were to combine these two equations together vertically, that means I'm going to add them. Well, 10x plus 9x would be 19x. Negative 8x plus 8y, negative 8y plus 8y, those are going to cancel each other out. So this is where step 2 comes in. That if our coefficients are opposite, we are supposed to add them together. So we're adding these cancel, And then if I add -2 and 59, I get 57. Well, now, look at step 3. It says solve the one variable equation, and this equation only has one variable. So to get y by itself, get x by itself, I need to divide both sides by 19. So x equals 3. I've now solved for x, so I have half my answer, because it told me I want to write my answer in an ordered pair, which means I need to write an x and then a y. Well, I know x is 3. Now I can substitute, so I can do step 4, which says substitute the known value into the other equation and solve for the remaining variable. What that means is to take one of my two equations, and it does not matter which one, and solve it for the other variable, to solve it for y. So I'm going to take the second equation, because I like it better because it's all positive. So I have 9x plus 8y equals 59. And instead of x, I'm going to plug in 3 because we just solved here and found out that x was 3. So it becomes 9 times 3 plus 8y equals 59. And this is now an equation that I can solve easily. 9 times 3 is 27, so 27 plus 8y equals 59. And I'm going to subtract 27 from both sides. So I end up with 8y equals 59 minus 27 would be 32. And then to get y completely by itself, I'm going to divide both sides by 8. And 32 divided by 8 is 4. So that would be the second half of my answer. So the ordered pair, the solution to the system of equations is the ordered pair 3, 4. So they've given us space to work all that out. So we're going to move down to the next example. So we're supposed to solve this system. 2x plus 4y equals -8, and -3x plus 4y equals 2. Well, the problem with this one is that my coefficients, I have 4y, but I have both of them as positive 4y. So what I want to do is I want to switch the signs in one of the equations so that one of them is negative. And we're allowed to do that because technically we can do whatever we want to one side of the equation. We just also have to do it to the other side. So that means I'm going to go down here to the bottom equation and I'm going to change it to a positive 3x, a negative 4y, and a -2. So I just switched all my signs. Well, now my y's are going to cancel, so I can combine 2x plus 3x is 5x, 4y minus 4y, those go away, and -8 plus -2 or -8 minus 2 is -10. To get x by itself, I'm going to divide both sides by 5, and I get that x equals -2. So again, I'm looking for my answer in an ordered pair format. I have half of it. I know that x is -2. So then I can plug that back in. I just need to pick an equation to solve for y. It does not matter which one you pick. I'm going to go with the first one. The first one said 2x plus 4y equaled -8. I've already solved for x, which was -2. Plus 4y equals -8. 2 times -2 is -4 plus 4y equals -8. And I'm going to solve this for y. So I'm going to add 4 to both sides. So positive 4y equals -4, because -8 plus 4 is -4. And then I'm going to divide both sides by 4. And when I divide -4 by 4, I end up with y equals -1. So the solution to this system of equations would be the ordered pair -2, -1. So for the page 15 section, it says the elimination method works when the equations are in standard form and the coefficients of one of the variables are equal or opposite. When they're talking about standard form, that means it's written in the form of ax plus by equals c. This is what we call standard form, where x and y are on the same side. So true or false, if the coefficients aren't equal or opposite, you can do a little manipulation so that you can still use the elimination method. That is in fact true. So this on page 19, we have a question that says, how can you get the coefficients that are equal for x? So I have 3x plus 2y equals 2 and 6x plus 3y equals 21. So if I wanted my x values to be the same, because I can only eliminate if they have the same number there, all I would have to do is multiply the top equation by something. And again, remember, we can do whatever we want to an equation as long as we do it to both sides. So if I multiply the top equation by 2, I would multiply every piece of it by 2. I'm distributing it in. I would end up with 6x plus 4y equals 4. Well, now my x terms in each equation are the same, and I could actually use that to my advantage so I could solve this problem through elimination. So as far as what the answer is in the blank, I would multiply the top equation by 2. So on page 20, we're actually going to solve this. So we've already multiplied the top equation by 2. So now it says to subtract the bottom equation from the new one. So I'm going to rewrite, and I'm going to do it over here to the side. We have 6x plus 4y equals 4. That's the first equation after we multiplied it by 2. And our second equation was 6x plus 3y equals 21. So now I need to combine these together. Well, it tells me to subtract them, but we also learned a few minutes ago that we can just switch all of our signs, which in some cases is a little bit easier. So I'm going to switch all the signs to the bottom row. I'm going to make that 6x negative, which means my positive 3y is going to become a negative 3y. My positive 21 is going to become a negative 21. So if I combine my like terms now, or if I add these vertically, negative 6x minus 6x, those are going to cancel. 4y minus 3y is 1y. 4 minus 21 is negative 17. So I have half of my solution. Because remember, we're looking for our solution in an ordered pair format. So we want it to be in the form something, comma something. We know y is actually negative 17. So to find x, I need to plug that back in. It does not matter which equation I utilize to find x. So I'm going to go back to the first one because my coefficients were smaller. So I have 3x plus 2y equals 12. I'm going to replace my y with negative 17. So I have 3x plus 2y, or plus 2 times negative 17 equals 12. So that would become 3x minus 34 equals 12. I'm going to rewrite over here because I'm out of space. So if I'm solving this, I need to add 34 to both sides. So I would end up now with 3x equals 46. And then lastly, to get y finally by itself, or to get x by itself completely, I divide both sides by 3. And I get that x equals 46 divided by 3. So that would be our solution. So the final solution is 46 over 3, comma, negative 17. That's our ordered pair. Moving on to the checkup. So we have number 1, 2x plus 5y equals 10, and 2x plus 3y equals 2. So in order to solve this, I need to make sure that I can eliminate something. Well, my x's both have 2 in front of them, which is good, but they're both positive, so I need to make one of them negative, so I'm going to switch all the signs in the bottom row. And then I can combine my equations. Well, my x's are going to cancel. 5y minus 3y is 2y. 10 minus 2 is 8. To solve for y, I divide both sides by 2, and I get that y equals 4. So for my answer, I know I'm going to write it in an ordered pair form. My y value is 4. So now I need to solve for x. So I'm going to pick one of my equations. It doesn't matter which one. So I'm going to pick 2x, my original, 2x plus 3y equaled 2. So I'm going to plug in 4 for y because that's what I found out y was when I solved. So I get 2x plus 12 equals 2. And then I need to subtract 12 from both sides. So 2x equals negative 10. And lastly, divide both sides by 2, and I get that x equals negative 5. So the second half of my answer, my x value, is negative 5. So the solution to this system is the ordered pair negative 5, 4. Number 3. 3x plus 4y equals 14, and 5x plus 4y equals 20. So again, I need to make one of my equations negative. Doesn't matter which one. I'm going to make the bottom one. I'm going to switch all the signs. So in that case, everything becomes negative. So 3x minus 5x is negative 2x. 4y minus 4y, those cancel. 14 minus 20 is negative 6. I'm going to divide both sides by negative 2, and x equals 3. So the first half of my answer is 3. Then I've got to solve for y. My equation, I'm going to use the first one. 3x plus 4y equals 14. But instead of x, I'm going to replace that with a 3 because that's what I found out y was, or x was. So 3 times 3 plus 4y equals 14. 3 times 3 is 9 plus 4y equals 14. I'm going to subtract 9 from both sides, so I get 4y equals 5. And then for my final step, divide both sides by 4, and I just end up with y equals 5 over 4. So my solution to this equation, this system of equations, would be the ordered pair 3, 5 over 4. So looking at number 5, they tell you that it's advantageous to first get everything in standard form, but as long as your equations are set up the same, you can go ahead and solve them the way they're set up. So what that means, and don't write this down, is that as long as if you draw your line through the equal sign, what's on the left side in the top one is the same as the left side in the bottom one, so they both have y on the left side, and that's it. And the right side both have x's and their numbers, then you're okay. Like you don't have to write this, but you could not solve an equation like 4x plus 3y equals 12 and 2y equals 7 minus 4x. You couldn't solve that particular system because they're not the way they're set up, where this 4x is on the wrong side. So as long as, with all that being said, as long as you have everything on the same side and it's all set up the same way, then you're good, which in this particular problem, everything is set up the same way. So we can go ahead and solve problem number 5. I need to eliminate something. The x's are going to be the best thing to eliminate because they both have 4x, but I need one of them to be negative. So to make the bottom one negative, I have to switch all the signs in the bottom row. So when I combine, 3y minus 4y is negative 1y. 4x minus 4x, those are going to cancel. 5 minus 7 is negative 2. And then dividing both sides by negative 1, I get that y equals positive 2. So as far as my answer goes, in an ordered pair, we know the y value is going to be positive 2. And now I just have to solve for x. So I'm going to substitute that back in. Doesn't matter which equation we use. I'm going to use the first one. So 3y equals 4x plus 5. Instead of y, I'm going to put in 2 because that's what I got here when I solved. So 3 times 2 equals 4x plus 5. 3 times 2 is 6 equals 4x plus 5. I'm going to minus 5 from both sides. I get that 1 equals 4x. And then I need to divide both sides by 4. So I end up with my answer for x is x equals 1/4. So that would be the other half to my solution. Moving on to question 7. Again, everything is set up the same way. My y's are on the left side, just y, and then x's and numbers are on the right, so I'm good. So I just need to eliminate, but I can't eliminate unless they have opposite signs. So if I were to make the bottom one negative, then I would have to switch all the other signs in that. So that negative y would become positive y, and my negative 4 would become positive 4. So if I add 5y plus y is now 6y equals, my x's cancel, and 2 plus 4 is 6. So I'm going to divide both sides by 6, and I get that y equals 1. So half my answer is 1. The x half is not 1. The y half is 1. I apologize. So now I just need to solve for x. So I'm going to plug it back in. I'm actually going to use the bottom equation because I like it a little better because it's got smaller coefficients. And I'm going to use the original, which was that negative y equaled 2x minus 4. So instead of y, I'm going to plug in there 1 equals 2x minus 4. So to get x by itself, I need to add 4 to both sides. Negative 1 plus 4 is 3 equals 2x. And to get x completely alone, I'm going to divide both sides by 2. And I get that x equals 3 over 2. So that would be the second half of my answer. So my ordered pair is 3 over 2, 1. Lastly, number 9. I have 4x minus 2y equals 0 and 3x plus 3y equals 9. And I need to solve this. The problem is none of my coefficients are the same. One of my x's is 4, the other one is 3. One of my y's is negative 2, the other one is 3. So that means I need to multiply by something. But I can't multiply 4 by anything to get 3. And I can't multiply 2 by anything to get 3. So this time I'm going to have to multiply both equations by something. So the easiest thing to do is to decide, number 1, which variable are you going to eliminate? And I'm noticing that the top one is y is negative and the bottom y is positive. So I'm going to try and eliminate those. So I'm going to have to multiply each equation by something. And in order to figure out what that is, you multiply by the opposite equation's y coefficient. So here, if I want to eliminate my y's, since this y on top has a coefficient of 2, I need to multiply the bottom equation by 2. Since my bottom equation, the y value has a coefficient of 3, I need to multiply the top equation by 3. And doing this will actually help us get rid of everything. So if I distribute that in, I get 12x minus 6y equals 0. And on the bottom, I get 6x plus 6y equals 18. And voila, now we have 6y and negative 6y. And so if I combine these together, because they're already opposites, 12x plus 6x is 18x. My y's are going to cancel, and 0 plus 18 is 18. So to get y by itself, I'm going to divide both sides by 18, and I get that x equals 1. So the first half of my answer is 1. Then I'm going to plug it back in. It doesn't matter which equation you use. I'm going to use the bottom equation. 3x plus 3y equals 9. Instead of x, I'm going to plug in 1. So 3 times 1 plus 3y equals 9. 3 times 1 is 3, plus 3y equals 9. To get y by itself, I need to subtract 3 from both sides. So 3y equals 6. Here you're right, because I'm out of space. And then to get y completely alone, I'm going to divide both sides by 3, and I get that y equals 2. So my solution would be the ordered pair 1, 2. Since that one was a little complicated, I'm going to solve problem number 8 as well. So for 8, I'm trying to figure out what letter I'm going to eliminate. It doesn't matter which letter you pick in either way, especially in this one because one of my x's has a 2, the other one has a 1, and one of my y's is a 3, and the other one has a 2. So nothing right away is going to eliminate, so I'm going to have to multiply no matter what. So let's eliminate the y's. You could choose to eliminate the x's and you'd end up with the same answer. If I'm going to eliminate the y's, I need to multiply by the opposite coefficient, which means I need to multiply the top one by 2 and the bottom one by 3. So if I distribute the top 2 in, 2 times 2 is 4x, 2 times 3 is 6y, and 2 times 4 equals 8. And then if I distribute the 3 in on the bottom one, I end up with 3x plus 6y equals 18. Well, I can't quite eliminate anything because they both have the same sign, so I am actually going to make the bottom one negative. If I switch that bottom sign, I have to switch all the signs in the bottom row. So 4x minus 3x is 1x. My y's cancel. And 8 minus 18 is negative 10. So there's half my answer. X equals negative 10. So now I just have to find y. So I'm going to plug it into one of my equations. Doesn't matter which one you pick, so let's pick the first one. So 2x plus 3y equals 4. X is negative 10, so 2 times negative 10 plus 3y equals 4. 2 times negative 10 is negative 20 plus 3y equals 4. So I'm solving, which means I need y by itself, so I'm going to add 20 to both sides. So I get 3y equals 24. And then I need to finish getting y alone, so I need to divide both sides by 3. And I end up with y equals 8. So that would be the second half of my answer. So my solution to this system is the ordered pair negative 10, 8.